Hi, hello, my name is Raja Rohan. As you can see on the screen, there is mobile price prediction. It is my project. Here, the problem is everyone buys mobiles, but they don't know what is the exact price and the price claimed by the company or the seller is valid or not. So, I've done a machine learning. I applied some machine learning algorithms on some data which is related to mobiles, which has weight, resolution, CPU frequency, internal memory, RAM, rear camera and front camera values, and the price of those mobiles. And you can see this is the data set I took. I collected this from Kaggle, and you can see the graph features versus target. Here my target is to predict here I am predicting price, so price is my target and all others are features. Here represents every scatter plot represents price versus product ID, price versus sale, weight versus price, resolution versus price, PPI versus price, CPU frequency versus price, internal memory versus price, RAM versus price, rear camera versus price, front camera versus price, thickness versus price, battery versus price, and these are my features to predict the price of the mobile. As you can see, these features with examples, and I implemented linear regression, support vector machine, k nearest neighbor, lasso regression, and ridge regression algorithms on my dataset to predict the prices. And linear regression, everyone knows that y equal to mx plus b is a equation for straight line. In linear regression, we plot the data, as you can see. Here. I imported NumPy, Pandas, and Matplotlib. From sklearn, I imported trend test split and minmax scaler. Here I read data with Pandas, cellphone.csv. It is a CSV file I uploaded through here, and I plotted graphs of every feature versus target. Here I done min-max scaling. Here I done trend test split, and here I defined a function linear regression, and then I took the transpose of this x train. And made a formula that is coefficients equal to x into x transpose whole inverse into y into x transpose, and I returned coefficients, and I will get the coefficients, and I from this linear regression function which I defined, and then with that coefficients I will form an equation. As you can see, I printed the equation here. This is the equation with 13 variables, 13 x values and 1 y value. These are all the graphs. And here I plotted the best fit. Here I tested the trained model with the testing data, and I find out the mean squared error, mean absolute error, and root mean squared error. As you can see here, errors from I got mean squared error as 28,947, mean absolute error 139, RMS error 170. and then I made this so that the user can enter their values and it will predict the price. And I also plotted the best fit line. As you can see. So then I implemented support vector machine regression algorithm on my dataset. I imported from sklearn SVR support vector regressor, and I imported matrices mean squared error and mean absolute error. I done the same thing which I done previously till training test split, and then I fit the data in SVR and I predicted from the X-test data, and I printed the mean squared error, mean absolute error and root mean squared error. As you can see here, mean squared error is 5,98,064, mean absolute error is 637, and root mean square error is 773. And I also created this product ID and so that user can enter this as I done previously in linear regression. This is the best fit line with linear regression. And errors in support vector machine. These are the errors in support vector machine. And then I done lasso regression. Lasso regression is almost same as linear regression, but it puts a penalty on every quotient so that they can't affect the target variable, or they can't dominate the all other features. So you can see I kept the penalty as 0.01. Here I imported a scalar linear model lasso and fit the data and predicted. I also printed the mean squared error and mean absolute error, and I also plotted the graphs of the coefficients over here, and then I created a user interface. And then I done lasso regression with PCA, principal component analysis. Principal component analysis will make the features. I had 13 features, but here I make those 13 features into 4 features, so that I can less features. There will be less features, and the time complexity of this program will be decreased. Here I imported sklearn decomposition PCA, and I fit the data. I fit the features in those, and split the train test and split the data into 2 train and test, and I done min max scaling, and then lasso regression same as previous. And see here I got only 4 coefficients for the line equation. Why? Because I decomposed the 13 features into 4 features, and then I done ridge regression without PCA, and I imported from a scalar linear model import ridge, train test split, min max scaling, data fitting, X train and Y train, predicting with X test, and finding mean absolute error and mean square error, and then plotting the graph of the coefficients, and then made a user interface like this. And then ridge regression with PCA. Here also I have made the 13 features into 4 features, as you can see here. I can make this into 5 features too. is running. See, 1 2 3 4 5 5 questions, so 5 features. I can make them into any number of features less than 13. And then I done k nearest neighbor regression. I have done this. Yeah, I have imported from sklearn.neighbors k neighbor regressor, and I have read the data from this. I copied the path, pasted here, and then fill the null values with mean, and then separated features and targets, and then split the data into two training and testing data. I done min-max scaling. Then KNN, I created a variable from this function which is already defined and written in K neighbor regression, and then I fit the data in KNN, and I trained the model here and tested the model here, and printed the mean squared error and mean absolute error, and then I made this user interface. I done KNN with PCA too. Here I just imported PCA and fit the data. Here I have made six n components, so 6 here I can also make 4 or any number less than 13, reducing the features and mainly reducing the dimension. And here I trained every model and found out the best model with low uncertainty and best model with low uncertainty. Here I have done linear support vector machine, lasso, ridge, KNN. As you can see, these are the importing libraries: NumPy, Pandas, sklearn processing, min-max scaler, sklearn. From sklearn, all these PCA, SVR, linear regression, ridge regression, lasso regression, train test split, mean squared error, resampling for bootstrapping, and matplotlib. Here I read the data from pandas and fill the null values with the mean of those column. I split the data into features and target, and then I done PCA. Here I defined the dictionary as linear regression, ridge regression, and then I created a dictionary and empty dictionary called results, and then I done bootstrapping over here. Sorry. Here I train the models with PCA. And here I done bootstrapping for 100 iterations. Bootstrapping is nothing but this function will make this loop will train the model 100 times, such that 100 times, and collects mean square error and uncertainty every time. For every iteration, it will find mean squared error and uncertainty. Here I have trained it for all 5 machine learning algorithms which I applied on my data set, and I plotted the graph for every uncertainty versus the model, mean squared error, uncertainty for linear regression, and finally I got the best model is linear regression with average mean squared error 27,175, and I plotted the correlation matrix with every feature and what is it? Product ID versus product ID versus price, product ID versus sale, product ID versus weight, and so on, like that, with every one versus everything. And these are the standard deviations for every model. Here I plotted mean squared error versus iterations. Mean squared error versus iterations. Of every model I implemented on my dataset. Here you can see bootstrap versus number of iterations in linear regression, and then lasso regression, and SVM, KNN, ridge regression. What is this? This is the explanation about KNN, lasso, ridge, regression. So finally I conclude that the best model for my dataset with bootstrapping is linear regression, and thank you.